This is going to be 8.1, triangles, angles, and radian measures. So far we've had different types of functions that we've talked about, but this chapter is going to be very particular because not all functions have an exponential growth or something looks parabolic. They can be very different. So, for example, one of these types of functions are what we call trig functions. And basically what trig functions are, these are just functions that model periodic behavior. Okay, so usually something that can probably model something like this can be maybe like the weather. Because if you think about the weather, sometimes you can have cold, then hot, then cold again. So you kind of have something that looks more like this. So something that, gets really hot, then back to cold, really hot, then back to cold, and so on and so forth. So also waves and sound. Trig functions are used a lot in physics. So that's mainly where you're going to be seeing them, and also in engineering. So there's a lot of things that you talk about to talk about with trig functions. But before we talk about trig functions, we want to make sure that we get our trigonometry correct and know a little bit of the basics. So a little bit of right triangle trigonometry. Just gonna write right triangle trig. And I think a lot of us have been familiar with something that looks like this. So if you have this triangle, and we're going to call this a right triangle. And from geometry, we know that this little box represents a 90-degree angle. So this is 90 degrees. And we also know that triangles all add up to 180 degrees. So these other angles can be anything that we want. So this guy can be something else, this guy can be something else, as long as they all add up to 90 degrees. So we know from right triangle trigonometry that if I label this A, this B, and this C, well, there is a relationship between all three different lengths. And we know that by the Pythagorean theorem. And we know that the Pythagorean theorem says that a squared plus b squared is equal to c squared. So, for example, if one of the lengths of my triangle was maybe 3 and the other length was maybe 2, then I can figure out what c is by plugging it into the formula. So we have 3 squared plus 2 squared equals c squared. This is going to give me 9 plus 4 gives me c squared. Then we're going to do 9 plus 4, which gives me 13, equals c squared. You take the square root. When you take a square root, you also add plus or minus. So c is going to be equal to plus or minus square root of 13. So typically, this is not correct because, in a triangle, you can't have a negative length. So c has to be only one possibility, which is the square root of 13 positive. So we've seen this before in maybe a lower level geometry class. So there is, if we know that this triangle is a right triangle, then we can use the Pythagorean theorem to figure out the other length, as long as this is a 90-degree angle. So it's a right triangle. If it's not 90 degrees or no angle is 90 degrees, we have to do something else. But but yeah, we are going to talk about two different types of triangles. So there's two special types of special right triangles. So there's two types. We will be using them a little bit, mainly for derivation use. So the first type of triangle is what we call a 30 degrees, 60 degree, 90 degree triangle, a 30, 60, 90. And the other one's what we call a 45, 45, 90. And this little symbol that I'm writing on the top just means degrees. So a little bit about what these triangles look like. A 30, 60, 90 looks something like this. So you have this triangle, a right triangle, and remember that a triangle can all add up to 180 degrees. Well, if I call this 60 degrees, the other one has to be 30 degrees. And notice that if I add 60, 30, and 90, I get 180. And then also, this one, if you have a 45, 45, 90 triangle, then this is 90 degrees, this is 45 degrees, this is 45 degrees, okay? And you can see that they all add up to 180. Now, why is this important? Well, if we have a 30, 60, 90, we basically know what the lengths are of these triangles. So, for example, this is 2, this is square root of 3, and this is 1. And for a 45, 45, 90, this is 1, this is 1, and this is square root of 2. Now, why? You probably are wondering. Well, here's a little derivation of why this is true. Because let's just say, okay, why is this true? Okay, why is it like that? If you start off by a regular equilateral triangle that has all the same lengths, okay, so for example, let's say this is 2, this is 2, and this is 2, then that means all of the angles are also going to be the same. So in order for this to be this, if the sides are the same, then the angle should be the same. And the only way the angles can be the same is if this is 60 degrees. So all of them are going to be 60 degrees. So what I'm going to do is that I'm going to divide this triangle by half. So I'm going to divide it by half. And I'm only going to look at this triangle right here, this guy. Okay, so if I take that out, you can see that this is 90 degrees, this is 60 degrees. Now this is 30 degrees because I divided it by half. This is still 2. Now this bottom part is now 1 because this is halfway of the whole triangle. Now what is this guy going to be? Well, we can use the Pythagorean theorem. If this is b, then we know that a squared plus b squared equals c squared. A is 1, b is just going to stay the same, c is going to be 2 squared. Okay, let me write it over here. So I have 1 plus b squared equals 4. Subtract by 1. B squared equals 3. Take the square root, b equals square root of 3. So you can see why this triangle is this way. Okay, now this is going to be something for derivation purposes, so you'll see the reason why we're doing all of this, because we will derive the unit circle using this thing. Now this guy over here, 45, 45, 90, well, it's kind of a little bit, this is a little bit more easy to figure out. So why is this way? Well, one way to kind of think about it is that you can see this 45 degree angle, and then you also have this 45 degree angle this way. Well, if you have these 45 degree angles, you can see that opposite of these angles, the size should be actually the same. So if I were to pick some point 1 and 1, right, then I can figure out the other one, which is going to be square root of 2 by just the Pythagorean theorem, because you know that 1 squared plus 1 squared is going to be equal to c squared. This is going to be 2 equals c squared, so c equals square root of 2. Okay, so that was a little bit easier to see, just because of the angles are the same. But the other one, the 30, 60, 90, is a little bit more unique, but you can still derive the formula. But that's just basically what it is. And so now notice that not all triangles are always going to be like this. You could have had another triangle that maybe had a 90 degree angle, but the other ones could have been something different. So for example, this one could have been 59 and this one could have been 31. So they're not always going to be a 30, 60, 90 or a 45, 45, 90. So not all angles are the same. So let's first start off by defining what an angle is. So angle. Okay, so an angle basically is formed when a line segment is rotated around one of its endpoints. Okay, and what do I mean by that? What does it mean to be rotated around one of its endpoints? So basically what this means is that if I have a line, maybe like that, okay, this is a line segment, okay, and I were to rotate this maybe a little bit, so I rotate it this way, okay, so if I went ahead and just swinged it, right, so that it's right here now, this little rotation is what we're going to call our angle. Okay, so this angle, usually what we have a symbol for it, we call it theta. Okay, theta. Okay, Greek letter for theta. Okay, now these guys have these line segments also have a couple words. So this thing is what we're going to call the vertex. This thing is what we're going to call the initial side. Okay, because that's where we start. And then this one's what we're going to call the terminal side, because that's where we end. Okay, so we have an angle is basically formed by taking a line segment and rotating it around one of its endpoints. Now, typically what we're going to do is that we're going to talk about initial size and terminal size in terms of the x and y plane. So if I have the x and y plane kind of like this, so here's the x and the y. This guy right here, I'm going to color it in green. This guy right here is our initial side. So the positive x-axis is going to be the initial side. So positive x-axis, let me write it right here. Positive x-axis will always be our initial side. Okay, and then when I swing this thing around, then I'm going to have various angles. So for example, this one, since I'm not rotating it at all, we can imagine that this is going to be 0 degrees. Okay, if I were to swing it all the way here, you know that this is going to be 90 degrees. Okay, because this is forming a 90-degree angle. If I were to swing it all the way over here, this is going to be 180 degrees. And if I swing it down here, okay, this is going to be 270 degrees. And if I did a full rotation all the way around, I'm going to go back to 360 degrees. Okay? So if I were to rotate it, this line segment starting here, and I were to rotate it over here, can you probably predict what this angle would be? Well, if this is 90 degrees and here's 0, halfway would be 45 degrees. So this is going to be 45 degrees. Okay? So similarly, we can do the same thing. We're going to go ahead and have my x and y. Here's my x-axis and my y-axis. Here is my initial side. We know that this is going to be 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So now let's say we want to swing it this way. So the other way around, okay, clockwise. Okay, well, if I were to swing it that way, it's still forming a 45-degree angle, but in this case, it's going to be negative 45 degrees. Okay, so what this states is that if I have a counterclockwise movement, so if this thing is counterclockwise, the angles are going to be positive. Okay, so what it means to be clockwise means going the opposite direction at which a clock is going. Okay, if I go in the clockwise direction, just how I did here, my angles are going to be negative. So in the direction that a clock goes. Okay, so my angles are either going to be positive or negative depending if I'm going in the clockwise or counterclockwise direction. Okay, all right, so in the next video, what we're going to do, we're going to talk about how do we find different angles that may not be in the 0 to 360 degrees. So and also how do we talk about angles that are coterminal and all that good stuff.